Hi students, this is lesson 98, graphing exponential functions. Today our goal is graph exponential functions. This is one of your standards for your class, and it'll be on the CASP test. You may have seen this before in prior classes, but we want to review it and reteach it to you. So why don't we have the students write this down. Let's have the teacher pause the video here for a moment and have the students write down what's in yellow. Alright, so exponential functions you might remember from before, but they could be graphed. They don't look like a line and they don't look like a U or a V. They actually look like they go up really quickly. And when we say they go up really quickly, they are having an exponential increase or exponential growth. Okay. Or they could go the opposite way from left to right. You could have an exponential decay. And so you'll need to know exponential growth and decay. The big idea here is, like, let's say you had populations of people double every so many years, or maybe having your money grow double every day, right? If I give you $1 today, and then tomorrow you get $2, and the day after that you'll get $4, the day after that you get $8, and so forth. Your money will grow pretty quickly if you got double every day. Okay, so these are the types of graphs. Here are the steps. Let's have the teacher pause the video here and have the students write all these steps down. Okay, students, you should have written this down. Now look at up here we have a standard form of the exponential equation, which is y equals a times b to the x minus h plus k, right? You might recognize x minus h in the exponent, right? That moves it left and right, and k would move it up and down. We're going to explore that more tomorrow, for the next couple days. Today we're just graphing, but just know that that's there. And we have an a and we have a b, which is our base. So you'll notice some similarities, but we'll explore what each part does to the graph, okay? So let's continue on. Today's goal is we're going to learn how to graph this, okay, by hand. And of course, on all of these, you could always check Desmos or graphing calculator before you finish, okay? So, but you do need to know how to do it by hand so you understand conceptually what's happening. So we're going to be putting inputs into our graphs here. So one piece of prior knowledge I want you to think about really quick. What's anything to the 0 power? Let's say a 3 to the 0 power, just a quick review. What's anything to the 0 power? It is 1, okay? Anything to the 0 power is 1. Anything to the first power is itself, right? And then one more thing. What is, well, let's do a few things. So what about x to the 0 power? What's that? That is also equal to 1, okay? One more thing, what about anything to the negative power? Let's say we had 2 to the negative first power. Just a quick review. Remember, this is like saying, we don't like that, we don't like a negative exponent, so it's like saying 1 over 2 to the first power, or 1/2, okay? You need to know this prior information before we start. Okay, so number 1, we want to graph. So we got y equals to -4 times 2 to the x power. So we're going to have our inputs going into the x, and then we're going to have an output coming out of the y. Okay. We want to start off by figuring out how do I make my exponent here above my base of 2 a 0. This one's easy because all I have to do is make x turn to 0. So we do that because it'll be easier to center our graph onto our coordinate plane. So we have 2 and to raise to the power of x. If I make x 0, we know it's going to be 2 to the 0. So I'm going to make an xy table, and I'll start with 0 in the middle, and then I'll pick some bigger numbers than 0, 2 bigger numbers. Let's pick 1 and 2 and -1 and 2. And then I'm going to plug in 0. Okay, so when I do that into here, 2 to the 0 power is 1. And then 1 times -4 is -4. Okay? So now we have an ordered pair of 0, -4 we're going to put into our graph in a minute here, okay? Then we're going to plug in the next number. Let's put in 1, okay? So putting in 1 here. 2 to the first power is 2. 2 times negative 4 is 8. Okay? And it's not just 8, it's negative 8. Okay, next one. 2. Let's put in the value of 2 in here. 2 squared is 4. 4 times negative 4 is negative 16. Okay? Now we're going to do negative 1 next. 2 to the negative first, remember what I said 2 to the negative first was? It was really 1/2, right? So this is 1/2 times negative 4. 1/2 times negative 4. What's half of 4? It's negative, or it's 2, but it's negative 2, right? So we're going to put in negative 2 here. And last, we're going to put in negative 2. When I put in negative 2 into x, it's like saying 1 over 2 squared, which is 1/4. 1/4 times negative 4 is going to be negative 1. Okay? We have all our points. And you can see there's a pattern on this one, right? As we go down, the numbers are being cut by a half. Or as you're looking from smallest to greatest, the number is getting bigger by 2. It's doubling, right? And that's where our base 2 comes into play. Okay, so now I'm going to plot my points. So plotting my points here, like ordered pairs, and I draw my graph and put some arrows at the end, and that's it. I put my graph so it doesn't keep going up forever like this, because it actually doesn't. If I keep putting in numbers, if I think what's the next number that is half of negative 1, it's negative 1/2, and so forth, and you'll notice that the numbers get closer and closer to 0. Anyways, that's number 1. Let me show you how to do number 2. A little bit more difficult, but we could do this, okay? We got 5 equals to, y is equal to 5 times 1/2 to the x plus 2 all minus 1, okay? So, the x plus 2, we have, we want to figure out how do I make this exponent equal to 0. So, how do I get this to be 0? 0 plus 2, or how do we make 0 out of x plus 2? What do I add to 2 to get to 0? Well, I add negative 2, because I know negative 2 plus 2 is 0. So I'm going to make an xy table like last time, and I'm going to start not with 0 this time in the middle, but negative 2. Pick 2 bigger numbers and 2 smaller numbers that will go in there, okay? And then I'm going to work this out. Okay, so let's put a negative 2 in here now. So I'm going to start with the middle one, negative 2, and you'll understand why. Negative 2, if we put it into the x here, negative 2 plus 2 is going to be 0, right? And anything to the 0 power is going to be 1, right? So we got 1 times 5 is 5. 5 minus 1 is 4. Okay? We do that again. Let's pick the next number. Let's do negative 3, right? Negative 3 plus 2 is negative 1. 1/2 to the negative first power is going to be 2. 2 times 5 is 10. 10 minus 1 is 9. Okay? For those of you confused what I just did, when I put in negative 1, negative 1 plus 2 is negative 1. Or 1/2 to the negative first is like saying 2 to the positive first, right? Because you're going to flip it. Okay? Let's do the next one, negative 4. Negative 4 plus 2 is negative 2. 1/2 to the negative 2 is positive 4. 4 times 5 is 20. 20 minus 1 is 19. Okay, so the next one we could do is negative 1. Negative 1 plus 2 is positive 1. And positive 1 to the 1/2 power is 1/2. And 1/2 times 5 is 5/2. So that's like saying 2.5, right? 2.5 minus 1 is 1.5, or we could say it's 3/2, right? Last one we're going to put in is 0. You got 0 plus 2 is 2. 1/2 to the second power is 1/4. 1/4 times 5 is 5/4, which is like 1.25. 1.25 minus 1. It is 1/4, okay? These are now all my ordered pairs, so I'm going to plot them. And I notice they turn very quickly. I'll put in one more point in, like I'll calculate 1, and then I'll notice that when I do that, I get -3/8, right? So I'm noticing it's kind of turning very quickly there. So I have a graph that is descending very quickly, and it is having an exponential decay. So anyways, these are two examples. You need to know how to graph them, and of course, where can you check your work? On Desmos, okay? So let's have the teacher pause the video here, and then let's have students write these down. Get a couple of rough graphs on your papers. Alright, kids should have written this down. Let's move on. Kids, I'd like you to practice this, okay? So you got two graphs here. Let's have the teacher pause the video here. Let's give the students 8 minutes, maybe put a timer on, 8 to 10 minutes, okay? And have students attempt these and graph them, and then when they are done, we're going to show them the answers. Let's pause the video here. Alright, so here are the answers for both of them. They both are exponential growth, and they both have some weird fractions going on, right? So part of this is practicing. The other part of this is you need to know how to do it, and then once we know how to do it, we can move on to knowing how each part affects it. So today was like a procedural lesson. Alright, so that concludes the lesson. I'll be back tomorrow, so ask me any questions about this, and then we'll move on with the next topic about exponential graphs, okay? Thank you so much. Talk to you later.